Affimer molecules are small single-domain proteins engineered to be an alternative to antibodies. They are generated very rapidly by in vitro library screening, so developing Affimer binders to new targets does not require the use of animals. The in vitro approach means that new Affimer binders can be identified much more quickly, with a typical Affimer to a custom target taking under 12 weeks to generate. This in vitro approach also means that a greater range of targets can be addressed, and that specificity can be controlled through design of the screening process. Affimer molecules are 12 to 14 kilodaltons in size, around 10 times smaller than antibodies. Several generations of the technology, including a version of human origin, are available to suit different applications. Affimer proteins have been engineered to display a binding surface similar in size to that of an antibody. This means that Affimer molecules possess similar binding affinities to antibodies, but with the benefits of a small, simple, and stable protein scaffold. Over hundreds of screens, we've found that high-affinity, highly specific target recognition is routine. Affimer molecules have a simple single-chain cysteine-free structure, making them very stable. They are easy to produce and highly flexible to engineer or label, with a wide range of markers, giving them performance advantages in several applications. Affimer molecules can also be chained together to bind multiple targets. For example, Affimer molecules can be efficiently immobilized on surfaces such as on beads or plates for purification, separation, or quantification applications. They can also be used as capture or detection reagents in various quantitative assay formats, such as sandwich ELISA, biosensors, or lateral flow devices. Chemical modifications, such as the addition of a fluorophore or a lanthanide, can be used to create superior imaging agents. Affimer molecules are a revolutionary new engineered alternative to antibodies that have significant benefits in numerous life science applications. They can be rapidly developed, have engineered specificity, are not limited by the immune system, they are highly flexible to engineer, and are easy to produce.